Good morning, everyone. This is Prasad BG, Assistant Professor, AJ Institute of Engineering and Technology. So today we'll be having a video lecture on engineering graphics, and the topic for today is projection of plane surfaces. So today's problem will be on projection of circular lamina. The question is, draw the projections of a circular plate of negligible thickness of 50 mm diameter resting on HP on a point A on the circumference with its plane inclined at 45 degrees to HP and the top view of the diameter passing through the resting point making 60 degrees with VP. Okay, not HP, VP. So first of all, when the question is given, you need to understand from where to start this particular problem, whether the lamina is resting on HP or resting on VP. So in the question, it's very clearly stated that the lamina is resting on HP. That means you will start your drawing below the XY line, that is from the top view. So what is the first thing we have to do? We have to start with the XY line. Okay, so we have written the XY line, VP and HP. So since the lamina is resting on HP, we will have to draw the circle below the XY line. So that is what I will do now. So we have drawn the circle here. Next, the circle has to be divided into 8 equal parts. So now there is no divisions on the circle. We have to divide the circle into at least 8 equal parts so that we get proper views in the next set of views. Okay, so you can see we have divided the circle into 8 equal parts. So how do we divide the circle into 8 equal parts? So the angle between them will be 45 degrees. That is, total angle is 360 degrees. So when you divide it into 8 parts, so each segment will be 45 degrees. Then we have to do the namings, and the namings has to be done in the order. So I have started with A, B, C, D, E, F, G, H in the clockwise direction. So that is about the top view. Now we have to get the front view. So we have to project these points to the XY line. Okay. So now the projection is being done. So now we have to draw the front view. So draw a thick line on the XY line and then again do the namings. So as you all know, in the top view, we give the naming as A, B, C, D, E, F, G and H. So when it goes to the front view, the naming has to be A dash, B dash, C dash and so on. So we are giving the names correspondingly. Where the point A is there, we call it as A dash. Then on the other end of that is E dash, which is the diameter, A dash, E dash. And the remaining points correspondingly, H dash bracket B dash, G dash bracket C dash, F dash bracket D dash. So that completes the first view. So now we have to move to the second view. So in the second view, we have to see the inclination with HP. So what is the inclination to HP given in the question? It is given that the plane inclined at 45 degrees to HP. That means what we have to do is take the distance A dash, E dash in the front view, which is on the XY line, and incline that line to an angle of 45 degrees. Okay, so exactly this is how we are supposed to do it. So A dash and E dash. So A dash will be touching the XY line and E dash will be on the other side, and do the corresponding namings properly. A dash, H dash bracket B dash, G dash bracket C dash, F dash bracket D dash. And one more thing you have to make sure is that these H dash B dash, G dash C dash and F dash D dash are not randomly placed. The corresponding distances are taken from the first view. That is, we take the compass, measure the distance between A dash and H dash. Same distance will be maintained here. Okay, I hope you understand that. A dash, H dash distance in the XY line will be measured in the compass. Same distance will be placed on A dash and cut an arc on H dash, B dash. Similarly, A dash to G dash will be measured and A dash to G dash will be cut on the compass, so that we get the proper distances in the second view. Okay, now we have to project this downwards. So projections has to come from A dash, H dash, G dash, F dash and E dash. So as you can see, I have drawn the projections properly. Similarly, the projections has to come from the circle, from the top view, that is A dash, B dash, E dash, so on. So you can see how the projections are being done. So now we have to know which point is A, which point is B. So the points where A and A dash meets, that is A. The points where B and B dash meets, that is B. Where C and C dash intersects, that is C. So we have to see it very carefully. Where is A dash line and where is A line? Where is it intersecting? The intersection points are the corresponding points A, B, C, D, E, so on. So based on that, we have marked the points A, B, C, D, E, F, G and H. Okay. So now, since it is a circle, so when the circle is inclined at particular angle, the top view what you are going to get is an ellipse. Right? When the circle it is tilted by certain angle, when you see from far, it will definitely look like an ellipse. So you have to join from A to B, B to C, C to D, not as lines but as curves. This is very important. Don't draw lines from A to B, B to C, C to D. It's not a pentagon or a triangle or a square to draw it using lines. These points to be connected as curves and a smooth curves. Okay, so ultimately what you're going to get is an ellipse. So you can very clearly see here, A to B is not a line or B to C is not a line, they are curves. So you have to draw it in the freehand very smoothly, you have to draw the curve. Okay, so that completes the second view. So moving on to the third view, so it says that the top view of the diameter passing through the resting point makes 60 degrees with VP. I have told you this earlier, the question it's written HP, but that is with respect to VP. Okay. So what we have to do is we have to draw a line at 60 degrees to VP like this. And then we have to place this ellipse, second ellipse, on the 60 degree line. So on which point it is resting? It is resting on AE, isn't it? It is resting on the point A on the circumference. So the diameter is AE. So AE line should be on the 60 degree line here. So we have to rotate this object in such a way that when we place it on the 60 degree line, the line AE should be coinciding with the 60 degree line. So you may have a doubt here. So should we be drawing the locus? Will there be an apparent angle? Will there be beta? Because usually what happens is when we say that inclination to VP and the length of the diameter changes, we have to draw the locus or we get the beta angle. But in this case, we don't have to draw the locus because it is in the question, it's very clearly stated that it is not the diameter is inclined at 60 degrees. It is said that the top view of the diameter. Can you read the question properly? It's written that the top view of the diameter passing through the resting point is at 60 degrees. So that means they're already talking about the top view, not the actual diameter. Okay, so I have told you this earlier also that whenever you have question, the diameter is inclined and appears to be inclined. The difference between is inclined and appears to be inclined. So if there is inclined, then you have to draw the locus. When it is given appears to be inclined, you don't have to draw the locus. So in this case also, they have not mentioned appears to be, but the other way of saying appears to be is top view of the diameter. So please remember, if there is a question where it is written appears to be or top view of that particular line, then you will not draw the locus. So without drawing the locus, as you can see, we have directly rotated this ellipse and kept AE line on the 60 degree line. That is the condition. We have to keep line AE on the 60 degree line. Okay. So it's easy to draw it in the software, but it is difficult to do it in the sketchbook. I need all of you to practice this properly because it's not that easy to draw in the sketchbook. So please make sure you draw this properly. Take your time and draw it in the sketchbook. Okay. So now that we have got all the points A, B, C, D, E, F, G, H, now we have to get the final front view. And how do we get that? We project all the points from the top view upwards and also like this, and also draw the projections from the front view in the second view. That is the line A dash B dash A dash B dash C dash D dash E dash line projected. So you can see you will project it, and also as you can see how I have projected it. Don't simply extend the lines beyond the the intersection point. Wherever the corresponding point intersect, please stop it at there, so that it becomes easy for you to locate the points. For example, you can see last point here is F on the right hand side, F and F, where it meets, we have exactly stopped it over there. So now you can do the namings, A dash, B dash, C dash, D dash, E dash. It becomes easy for us to mark the corresponding points. And now again, don't join it by lines, you have to again join it by curves. So since this is also an ellipse, so again you will draw this by curves. So you will get a curve like this. So this is the final view. So you can see this is the circular lamina resting on HP, inclined at 45 degrees to HP, and the top view of the diameter is inclined at 60 degrees to VP. So this concludes the problem. So we will then go to the next problem.